All right, so for the line that has a slope of -1/5, let's go ahead and use our point slope form. So it's going to be y minus 1, y minus the y part of my ordered pair equals -1/5 times x minus 3. What would I do from there? I need to distribute that -1/5. So y minus 1 equals -1/5 x plus 3/5. Add 1 to both sides, and I can get this in slope-intercept form. Y equals -1/5 x plus what? 8/5. So there's the equation for our green line. Y equals -1/5 x plus 8/5. All right, we're going to graph a couple more lines today, and then we're going to move into using our different forms. Three more graphs for us.
Did you teach in the 2000s?
Did I teach in the 2000s? No, it wasn't until, I mean, technically yes right now, but just the 2000s. My first year here was 2014.
Oh.
So
you missed the good stuff.
I was busy raising young children at that point. All right. What would be the easiest and most straightforward way to graph line A here? Yep. +1 is my y-intercept. And we have a slope of 2. So I'm going to start at 1 on the y-axis. From there, I'm going to go up 2 into the right 1. Up 2 into the right 1 until I can't go any further. Turn it around and go the opposite direction to get the most precise line you can. And then we grab our straight edge and trace through it. Yes, if you want rulers, if you want colored pencils, absolutely, you may have those on the test. All right. And once you get the line sketched on there, what do I need you to do? Label it. I want to label this line so that I know which line goes with which equation. Equation B, what form is equation B in? It is not in slope-intercept form. It's in standard form. Standard form doesn't have the nice, easy graphing hacks that slope-intercept form has. We can change it. Let's go ahead and change it into slope-intercept form. I'm going to subtract 2x from both sides. So I get -5y equals -2x plus 8. Divide everybody by -5. Y is equal to 2/5 x minus 8/5. A slope of 2/5 isn't so bad. Up 2, right 5, up 2, right 5. I don't like what I see in front of me for graphing now. I'm not going to be able to be very precise because of which piece? The y-intercept. I really want a nice clean point and then count from there. So let's find a different point. Once I have any point on this line, I can use the slope to get more points. It doesn't have to start with the y-intercept. How could I find another point on this line that would be nicer to graph from than a y-intercept of negative 8/5? What'd you say? We could sub something in for the y value.
Wait, so you want like exacts when it comes to it?
When we're graphing these, we want to be as precise as possible. So if there are any nice whole points on this line, we want to get those graphed. The y-intercept is not pretty. What's another easy to find point? The x-intercept. How do we find the x-intercept? Put 0 in for y. I'm going to go back to the original and put 0 in for y in the original one and see what we get. All right, so let y equal 0. So 2x minus 5 times 0 equals 8. So that just becomes 2x equals 8. Is my x-intercept nice? 4. So my x-intercept would be 4, 0. And we've got our slope. I'm going to go plot that x-intercept, 4, 0. From any point that is on the line, I can use the slope to find another point. So from here, where do I go? Up 2 and right 5. And I can back it up and go the other direction as well. Down 2 and left 5. Down 2 and left 5. And then grab my straight edge from there. I want to label that line. So that is 2x minus 5y equals 8. One more line to graph. What form is this line currently in? Point slope form. All I need is one point and the slope, and I can graph a line. So let's write down the point that this form is telling me. What is the x part of this point? Negative 1 for the x part. What value of x would make that 0? Negative 1. What is the y part of the ordered pair for the point they're telling me? 2. Negative 1, 2. Yes, so that 1/2 in front is my slope, but it's not telling me the point that they're giving me. Because remember, point slope form is y minus y1 equals m times x minus x1. So slope is out in front by itself. I don't have to distribute it to find the x part. I understand where that idea came from, though. So good thinking. What is the slope for this line? 1/2. So we're going to go plot our point, negative 1, 2, right here. And then from there we can use our slope. Up 1, right 2, up 1, right 2, until we run out of room on our graph. Back it up the other direction. And grab my straight edge. Make sure you put arrows on the ends of your lines and make sure that you label your lines. So y minus 2 equals 1/2 times x plus 1.
Do we have to label it if we use colors?
If you use colors, no, you don't. Just make sure that you circle or write the equation in that color and then graph the line in that same color. That would be perfectly fine. Or yesterday, I think it was Matthew that had asked, can we call it line A, line B, line C, and then I label my lines that way? That would be fine as well. I just need to be able to clearly identify which line goes with which graph. Are the purple and red line ever going to touch?
Yes.
Yes. How can you tell?
They're not perfect.
They're not perfectly parallel. They do not have the same slope. Give me the general direction that I would need to look in if I was going to zoom out for where they would cross. Left. Kind of lower leftish area. All right.
Quadrant 3.
Yes, somewhere down in quadrant 3. All right, finding slope. We practiced this a little bit in the last unit. y2 minus y1, this is the change in my y values. That's the same thing as my rise. So we are subtracting our y values to figure out the difference between those two. Yep. Or on a graph, the idea here is like, how far would I count between these two? When you subtract those two y values, you're finding the distance between them. Rise over run. Run is the change in my x values. So I want to find the slope between these 2 points. All right, so slope equals, I know I'm going to be subtracting things. Does it really matter which one I decide to call point 1 and which one I decide to call point 2? Like, would it be different if I said this was point 2? Would I get a different slope? No. It shouldn't depend. What you do have to watch out for, though, is that the numbers that you stack here in the fraction, so on top of each other, one in the numerator and one in the denominator, those should be coming from the same ordered pair. So the ones before the subtraction should come from one ordered pair. The ones after the subtraction should come from one ordered pair. So for example, if I let point C be my point 2, so that's the one that I'm doing first, change in y goes in my numerator, change in x goes in my denominator. So I'd want the y part of the ordered pair on top and the x part of the ordered pair on the bottom. Same thing with D. I want the y part of the ordered pair in my numerator and the x part of the ordered pair in my denominator. Just to make sure that I am not leading you astray, we're going to make sure that we get the same thing even if I switch it around. So this would be 2 plus 7 in my numerator. Down on the bottom, I would have 3 plus 9. So 9 over 6. Can that reduce to 3 halves? If I switch it around and I put the coordinates from point D first and the coordinates from point C second, I would have negative 9 over negative 9 plus 3. So negative 9 over negative 6, which would reduce to what? 3 halves.
But you're not always that lucky.
I'm not what?
Always that lucky.
It's not a matter of luck. It's not a matter of luck. You have to stay consistent. This will work when you reverse it every time, as long as the numbers that you put on top of each other in the fraction came from the same ordered pair. So like what I have circled in orange there, it either needs to be those two numbers first on top and first on bottom, or they need to be together, both of them behind the subtraction sign. So this isn't a sometimes true thing. y2 minus y1, x2 minus x1, it doesn't matter which point you call point 1 and point 2, as long as you stay consistent in your numerator and your denominator. Does that make sense?
Yeah.
Okay. All right, so we found our slope here. How do I know again if two line segments are parallel? They have the same slope. How do I know if they're perpendicular?
Inversely.
Sort of. Inverse, yes, or reciprocal, but then they also have to have the opposite sign. Yep. So parallel lines, same slope. We have shorthand for parallel that you might see that I would use in notes sometime, or you might see printed in a textbook or on a test. 2 slanted lines side by side is our shorthand for parallel. Don't do them straight up and down because then it just looks like 2 L's. If we give them a little bit of a slant, then I know I mean parallel instead of just double L.
Or if you do it on the side, it looks like an equal sign.
Perpendicular, the slopes have a product of -1, which is just another way of saying opposite and reciprocal. So, for example, if I had 2/5 and -5/2, those would be opposite reciprocals of each other. And if I multiply them together, I get a product of -1. Does anybody remember the shorthand that we use for perpendicular, the symbol that we use for perpendicular? Yes. Upside down capital T. Looks like it forms 2 right angles right there. So far, so good?
Or 2 L, 1 L forward, 1 L backwards.
I suppose you could look at it that way. All right. We're going to use just the idea of slope to show that 4 points that I'm getting ready to put up are the vertices of a rectangle. We did this before using distance and slope. We're going to use just slope now. What properties of a rectangle could I use if I was only going to use slope? Yes, sir.
Parallel and perpendicular.
How many sets of parallel lines would we have?
2.
2 sets of parallel lines.
2 bisectors.
Yes. Actually, I think it's more than just 2 perpendiculars.
Well, I'm talking about 4.
Yes, we would need 4 right angles.
I'm talking about for like each parallel lines, like 1 parallel line meets one of the other parallel lines, like every time.
Yes, which altogether would mean 4 right angles or 4 sides that are perpendicular. So this is what I'm going to have to show. I can jump right in and find slopes, but with 4 points like this, I can find a lot more than 4 slopes. I want to make sure that any of the slopes that I'm finding are actually the sides of the rectangle and that I don't bother finding the diagonals. So I'm going to do just a real quick, incredibly rough sketch off to the side to make sure that I know what are the pieces that would be the sides of this rectangle. So 6/15, that's going to be over here somewhere in quadrant 1. 11/12, I'm going to be further to the right, but not as high. So there's B. C is -1, -8, so he's going to be way over here in quadrant 3. And point D would still be in quadrant 3. It's going to be further to the left and not quite as low.
I think that's a rectangle.
Hmm?
I think that's a rectangle.
I think it is.
But we have to prove.
Looks about right.
We have to prove that it's a rectangle because there are all kinds of things that look like rectangles that aren't.
It could be a little bit off, and it'd be like, I don't know.
It absolutely could be a little bit off.
It could have been a diamond on its side.
Rectangle enough for me.
So if we are going to show, remember show means prove. I need to find all of the slopes, and then we're going to very clearly state these relationships. Which ones are parallel, and I'm going to have the evidence to back it up. Which ones are perpendicular, and I'm going to have the evidence to back that up. So let's find the slope of AB first.
It's lucky A, B, and C all go in order.
It's nice when that works. It doesn't always work that way, which is why I did the little sketch. Because again, I want to make sure that they didn't try to trick me by putting 2 points next to each other that are actually forming diagonals here. What do I subtract to find the slope of AB? 12 minus 15 over what? 11 minus 6. 12 minus 15 gives me -3. 11 minus 6 gives me 5. So here's the slope of AB. For the slope of BC, what am I subtracting? Negative 8 minus 12 in my numerator over what? Negative 1 minus 11 in my denominator. Negative 8 minus 12 is negative 20. Negative 1 minus 11 is negative 12. So what is my slope here? 5/3. Can I say anything about parallel or perpendicular lines at this point?
Yes.
Yes. What can I say?
There's perpendicular.
Yes, I can say that AB is perpendicular to BC. These are opposite reciprocals here. All right, let's keep going. We're going to find the slope of CD. So what are we subtracting for CD? Negative 5 minus negative 8 over what? Negative 6 minus negative 1. So I have negative 5 plus 8 and negative 6 plus 1. So how does that simplify? Yes, 3 over negative 5 or negative 3/5. Can I say anything about parallel or perpendicular at this point?
Yes.
Yes, what can I say? AB and CD are parallel. Can I say anything else?
BC and CD are perpendicular.
Yes.
So do we have to test AD and see against?
Yes, we do.
Because that could be not parallel.
Yep, it is possible that that one would not be parallel to BC, and therefore it would not be perpendicular. Oops, bring this through like this.
Very rare chance that will appear on the homework.
It is always possible, which is why we talk about it. I want to make sure that I am preparing you for anything you might see here. All right, so last one. We need the slope of AD. What am I subtracting? Negative 5 minus 15 over negative 6 minus 6. So negative 20 over negative 12. We already reduced that one down once. What does that simplify to? 5/3. All right. We still have a couple statements to make. Right now I only have one set of parallel lines and I only have 2 right angles. So what other statements do I still need to make? BC and AD are parallel. Now I have met this criteria. And I have the slopes to prove it. What else can I say? AB and AD are perpendicular. Can we say anything else is perpendicular? I need 4 right angles. I've got 3 right now.
CD and AD?
Yes. CD is perpendicular to AD. Now I have my 4 right angles. I need to see the slopes, and I need to see you actually make the relationships. Tell me which are the parallel sides. You have the slope to back up your statement, but you need to actually make that statement also. So far, so good?
So you want to show, just write it out like you did at the top right there.
Yep. Yeah, if you were doing this on a test or a quiz, I'd want to see your slopes at the bottom, but then I want to see you actually make the connections, because that's where you show me that you know parallel lines, same slope, perpendicular lines, opposite reciprocal. All right, let's find some general form equations. What does general form look like?
Is that the AX one?
Yes. That is the AX plus BY equals C. Looking at that form, I see that X and Y have to be on the same side. What other criteria does it have to meet in order to be considered general form? Yep.
And no fraction.
A is greater than 0 and no fractions. So A, B, and C are all integers. All right. So let's see if we can write some general form equations for these. I want the equation of a line that goes through the point 5, -2 and is parallel to the x-axis. Sorry, to the y-axis. Parallel to the y-axis. What kind of a line are we going to make then? If it is parallel to the y-axis. Yes, this is going to be a vertical line. All right, so I'm just going to do a real quick sketch here. 5, -2 is like here. And we said we want a vertical line through that point. So what's the only axis that it's going to touch then? X, which means I only have X in my equation. If it's a vertical line, I'm only going to have X in that equation. So X is equal to, where is it going to go through the x-axis at? At 5, the x part of this ordered pair. So X equals 5 would be my equation, and I'm done.
Can you do X equals 5, 0, Y?
5, 0, y like that?
No, I suppose 5, 0, 1. So it'd be like Y times by 0, there's always 0.
Technically, that would not be wrong, but it's not fully simplified because y times 0 simplifies further. Good question. What kind of line are we drawing if it is going to be perpendicular to the y-axis? Yes, it would be parallel to the x-axis. This would be a horizontal line. So parallel to the y-axis, it's going to be doing this. Going through that point that they gave me. And I see that it makes a right angle here. So if it's perpendicular to the y-axis, it's a horizontal line. What is the only axis it will actually go through? The y-axis. Which means, what about my equation?
Only a Y.
Only has a y. It does not have x and y unless it's going to touch both x and y. So y equals what? -2, the y part of this ordered pair right here. So far, so good? All right. What did they give us to work with on part C? A point and a slope. So even though I need to end up with general form, what form should I start off with? Point slope form. Start, not state.
If we're going to state the,
Yep. Start with point slope form.
well, don't we have to state it first, then do it?
No, not really. All right, point slope form again is y minus y1 equals my slope m times x minus x1. So let's substitute in what we know. Y minus what? -3 equals my slope, -4, times x minus what? X minus 5. So we substituted in our point and our slope. I'm going to clean this up. That's going to become y plus 3. With my negative 4 over here, I'm going to distribute that. So I have negative 4x plus 20. What do I need to put this into general form? What needs to be the case?
Get y intercept.
Not y on its own. That'd be slope-intercept form.
needs
So
to
you
be on
want
the
to
side of
put,
X.
you have to
Yes.
put 20 back over and move y to the other side.
I can move y to the other side, or I could move the x to the other side. I just need
Yeah.
x and y together. Since I know I want my leading coefficient to be positive, I'm going to add 4x to both sides. 4x plus y plus 3 equals 20. What would I still need to do now? Subtract 20. Oh, subtract 3. Sorry. My apologies. 4x plus y equals what? 17. All right. Let's do a couple more like this. They're giving us conditions. They're telling me a point that it has to go through and giving me one other condition that it has to satisfy. We are coming up with an equation, and then we're converting it into standard form. So far, so good? For part D, what did they give me? 2 points. We need to write this in standard form, but all they gave me is 2 points. What form should I start with?
Radical lines, so you get the slope, and you use the slope formula, then you use slope formula to standard formula.
Slope formula doesn't give me a line. I do need the slope, but that's not a form of a line. What form of the line should I start with?
Did you start with point slope one?
Yes, I would start with point slope form here. So I am going to have to find my slope. Then I pick one of these points. It does not matter which point we choose to substitute into point slope form. And then we'll convert it into standard form from there. All right, so to find my slope, tell me what I'm subtracting. I need rise over run. 6 minus negative 5, so 6 plus 5, over what? Negative 3 minus 4. 6 plus 5 over negative 7, so I have negative 11 sevenths for my slope. So far, so good? All right. Point slope form, y minus, which point do you guys want to use? A or B?
A.
Okay, let's use A. So y minus what? Negative 5 equals negative 11 sevenths times x minus 4. All right, so first thing I see here, I would really like to distribute that negative 11 sevenths. And I'm going to change this to a plus right here. So y plus 5 equals negative 11 sevenths x plus 44 sevenths. I do not really want to try adding and subtracting fractions if I don't have to. Standard form isn't supposed to have fractions at all, is it? So what could I do to get rid of these fractions so that I don't have to deal with them? Multiply everybody by 7. Multiplication will undo that division. So we'll get rid of my denominators over here in both of these. So I'm going to have 7y plus 35 equals negative 5x plus 44. Sorry, negative 11. I misread my number. Horribly. Where to from here?
Minus 35 at 11.
Yes, add 11x to both sides and subtract 35 from both sides. And so we get what as our standard form? 11x plus 7y equals 9. All right. For part E, what information did they give me to work with?
It's parallel.
It is parallel to this line. How does that help me? Same slope. So if I can find the slope of the line they gave me, then I have the slope of the line I'm looking for. Once I have that slope, what form should I begin with before I convert it to standard form? Do I have my intercept? Point slope form. Let's use point slope form after we get our slope. So I'm going to take the line that they gave me. I'm going to put that one into slope intercept form so that I can identify the slope. So I'd have negative 2y equals negative 5x plus 4. Divide everybody by negative 2. So y is equal to 5 halves x minus 2. Here's the slope I want. And I have the point already. They gave me this point right here. So it's going to be y minus what? Y minus negative 4 equals 5 halves is the slope that we want, times x minus what? Negative 2. All right, so let's clean up, and I'm going to distribute. So I'm going to have y plus 4 equals 5 halves x plus 5, right? Okay. I'm not supposed to have fractions in standard form. Times 2. Everybody gets doubled. So that's going to get rid of my fraction there. So I'm going to have 2y plus 8 equals 5x plus 10. What do I do now? Subtract, I heard subtract x. Okay, I'm going to subtract 5x from both sides. I'm going to subtract 8 from both sides also. I'm going with the suggestion from class. There is another way to go about doing this. Negative 5x plus 2y equals 2. Am I done? Is that standard form? There's a negative. So how do I get rid of it? Divide everything by negative 1. Or multiply everything by negative 1. So 5x minus 2y equals negative 2. All right. We're going to finish out part F. We're going to call it a day at that point. Your quiz that was originally scheduled for tomorrow is being pushed back to Thursday so that we have time to finish this. All right. Huh?
The calendar paper where it tells you what day each quiz is.
Yes, I need to print that out and give that to you. What do I know on this last one? It is perpendicular. So what does that tell me? Opposite reciprocal slope. Which means I need the slope of this guy. So negative 5y equals negative 2x plus 8. Y equals 2/5 x minus 8/5. So here's the slope of the line they gave me. What is the opposite reciprocal that I want to be using then? Negative 5/2. And then I'm going to use point slope form. So y minus 2 equals negative 5/2 times x minus negative 5. Y minus 2 equals negative 5/2 times x plus 5. I'm going to distribute that negative 5/2. Y minus 2 equals negative 5/2 x minus 25/2. Get rid of my fractions by doing what? Multiplying everybody by 2. So I have 2y minus 4 equals negative 5x minus 25. What is this going to end up like when I get the x to the other side and I add 4 to both sides? 5x plus 2y equals negative 21. There's my standard form. Homework due date is getting pushed back a day. Quiz is on Thursday, not tomorrow. I will update our Canvas page to reflect that. We still have 2 story problems and a couple other short things to do in this section. And then we will start 3.4 tomorrow when we're done with 3.3.